Hi, look at this code snippet here. So it's a long constant which is actually calculating the number of microseconds per day. That is, so the first number indicates the number of hours in a day, 24 multiplied by 60 gives the result in minutes, and then it is multiplied by 60 again to get the value in seconds, and it is it is multiplied by 1000 to convert the product into milliseconds, and finally we are again multiplying it by 1000 to get the microseconds per day, right? And in the same way we have another long variable which actually computes the milliseconds per day, right? So now what we wanted to do, we wanted to calculate microseconds divided by milliseconds per day, right? So what do you think the program prints? So it's clear that it prints 1000, right? So let's verify it. So you can see here, to our surprise, it actually prints 5. So let's check what's going on here. The problem is that the computation of the constant here, right, the microseconds per day, right, is performed in int arithmetic, right? So why? Because all the factors that are multiplied together here are int values, and only after the computation is completed, the result is promoted to a long variable, right? But by that time, it's too late. The computation has already overflowed, returning a value that is too low by a factor of 200. And it is divided by milliseconds per day, right? So which was computed correctly because it does fit in an int range. So the result of the division was 5, right? So this happened because the entire computation was int arithmetic, as Java does not support target typing. That is, the type of the variable that stores result influences the type of computation, but that is not supported by Java language. So it's easy to fix. We just need to use a long literal here for the first factor in the product, right? So you can just put here long literal for each of these products, though it is not required for milliseconds per day, as this does fit in an int range. So it's always a best practice when you're not sure of whether the product actually fits in an int range or not. So it's better you actually have a long literal here, right? And in the same way, like which actually when we put this long literal here, this actually forces all the subsequent computations in this expression to be done with long arithmetic, right? So again, you don't need to have this long literal for the first factor in the product, but it's again a best practice so that we can make sure that the product won't overflow, right? So now let me execute this program and verify. So you can see now we get the expected output 1000, right? So some summary is, when working with large numbers, watch out for overflow. So it's a silent killer. Just because a variable is large enough to hold a result doesn't mean the result of the computation is of correct type, right? So when you're in doubt, perform the entire computation using long arithmetic. Thanks for watching. If you like the video, please like, subscribe, and share it.